Good morning, good evening. Let's give 5 minutes for everyone to join and then we can get started.
Hello.
Hey, Rad, how are you?
Doing well. Thank you very much.
Hi, Dinat. How are you doing?
Hey, hi, Emily. I'm good. Thank you. How are you?
Perfect.
Yep, let's give 4 more minutes for people to join and then we can get started, please. Hey, I think the question was from. So sorry, actually, we cannot move this on Thursday. We had it initially, but we moved it due to daylight savings. So it's every Wednesday. Like most of them are available, that's why. But yeah, maybe move the feedback or survey toward all the clients and let's see if everybody is ready for Thursday. Yeah, we can have it on Thursday as well. Oh, okay.
Before we start, can I ask something? I was watching the videos and I don't know if it was mentioned or if I missed it or not. But I don't know how to encode some fields. For example, fields like employee name, employee email, things that are usually encoded when I am trying to access them within my organization. They sometimes even have extra layer of access needed. Uh, I I don't know if that is
Yep, I
needed.
think we'll get back to you. Milada will get back to you on that. She might be able to help you. Okay.
Okay.
Cool. I think we will get started. Uh, okay, let me know once you can see my screen, guys.
Yes, we can. Dinat.
Yes, we can.
Yes. Great. Okay, so today's call is all about system designs into data engineering. Okay, this is a very important topic for all the students or all the candidates who are applying job for 3+ years as well. Because these days system design has been important even for a data engineer. It is very important for senior data engineer for sure, but it is also important for data engineers, associate data engineers sometimes. But from data engineers onwards, system design is important. So that's what today's class is about. So we might have continuous session of system design at least 5 to 6 because we cannot cover everything in one group call itself. So I'm just going to cover some basic part of system design today, the beginner part. Then next part would be beginner second part, and then next 4 calls will be intermediate 1, 2, and advanced 1, 2. So to start with, yeah, I'll be sharing this document as well in the school classroom. Everyone can access it there and they can download as well. So I'll just start with the definition of system design in terms of data engineering. So system design is nothing but you're going to design an architecture or the infrastructure where you move data from source to target based on your business requirement, and that architecture should consider all the requirements, as well as it is important that you plan what you're not seeing in a present time, but you might see it in future. So there are some consideration when you do a system design, like cap theorems. You need to check if it is asset compliance and all those things, right? All those things need to be considered during system design. So system design, in short, is a planogram or a plan or an architecture. I'll show you what does it mean. And you design that for data lakes, data warehouse, or your ETL flow. Not just ETL flow, even if it is extract and load. So anywhere, if you're moving your data from source to target, you're going to have a system design. I mean, it's not every time compulsory that it should be ETL or ELT. It can be a simple, there are some API calls you need to do from a Lambda, and you need to write some data to S3. How are you going to design that system as well? So why it matters? What is the importance of system design? So when we are productionalizing our pipelines or productionalizing data engineering objects, it's very important that your data flow should run smoothly and efficiently. Now, what does it mean? There shouldn't be any errors. It should it should be able to run very fluently and smoothly, considering volume, velocity, or variety of data. So these are three V's of big data. That is, even if volume is huge, it has PB's worth of data. Even if the velocity as in every 15 minutes, if you're getting records, every 5 minutes you're trying to get the records, then too you should be able to move your data or move your data from source to target. A variety of data, as in if you're receiving CSV, JSON, Sparky, XML, multiple kinds of data. Whatever system is designed, that should take care of all these three V's. And to do that, there are certain rules you need to follow, which I'm going to explain over here. The very basic thing, or before going ahead, any questions of the system design definition and why is it important?
I have a question, Ninad. Can I ask?
Sure. Go ahead.
So when we talk about system design, right? So we need to talk about like a discussion, right? We need to ask the questions to the interviewer, like what type of system they need, like that, and then we need to design system, right? Or do we need to just tell our approach and assume a few things and just start with that? Or
so usually in interview, just to show you, just to give you a quick tip, what happens is, me as an interviewer, I'll give you a requirement. You'll have to explain me in wordings, not really like draw it and show it. I'll give you a requirement, and you will have to give an answer in terms. I will show in the next 30 minutes an example or real world interview question as well, how it happens. So basically, interviewer gives you a requirement. Based on your experience, you need to choose the best design for that particular requirement. Now, while designing that requirement, you will have to consider whatever I'm going to tell you.
Okay. Thank you.
So, starting with cap theorem, it's a very basic and very important part of the system design, which includes consistency, availability, and partitions. Okay. So what does this mean? I'll be explaining you. But out of these three concepts, consistency, availability, and partition tolerance, minimum in 99% of your data engineering architectures, only two properties are fulfilled out of three. Okay, only two of three properties can be fulfilled in one architecture. So let's say if your architecture is partition tolerant, then either you will have consistency or you will have availability. And what are these two terms? I'll explain now. But yeah, this term was first asked by Eric Brewer, so it's called as Brewer's theorem as well. So whenever you're going to do a big data distributed system design, if you're going to do data lakes, delta lakes, data warehouse design, cap theorem is, I would say, underground basic concept of every design. Okay. Now, what does consistency means in your cap theorem? In consistency, you need to ensure that whatever you're writing to your target or whatever is copied from your source data, it needs to be written in the same manner. So let's say you have designed an SCD1 logic and you want to update employee's location if it is updated in source. Every time that consistency should be maintained. Okay. This is very important in terms of accuracy when it comes to the financial transactions, because you cannot mess up with financial transactions and amounts as well, right? So a good example of consistency is with Goldman Sachs. So a financial services company like Goldman Sachs ensures that all the transactions which are coming through their trading platform are correct and consistent. So every read operation that is retrieved through your system should be recorded in an actual manner, and it shouldn't have wrong calculations or something like that. So you need to maintain that integrity of that financial data. So this consistency should be the first part of your data engineer or system design. Second part is availability. Okay, now availability is when you're designing a system, that is, you're moving data from source to target. Someone needs to read that data. You will have a business requirement, right? That someone is going to read that data, correct? So your data should be always operational, and it should be able to handle thousands of reads and write in parallel as well. So let's say someone is reading your data. There is a business user XYZ, and your data engineering team has developed an ETL pipeline. If it is writing some data and parallelly someone is reading, there shouldn't be an isolation or lock on the table. So you need to be aware about availability of your system as well. Netflix is a very good example of that. In the streaming service, they need to prioritize the highest availability possible, because no buffers are going to be acceptable when you buy a subscription or premium subscription, right? So Netflix is a very good example of the availability. Moving to partition tolerance. So example of partition tolerance, I'll give you I'll give a definition in terms of example. So your system design, or whatever design you have given in a system design, or whatever plan you're going to give, it shouldn't have any network errors or network partitions, as in it shouldn't go offline anytime. If it goes offline, then your availability is not possible, and then your consistency is also not possible. So the very first main part would be, whatever you're designing on cloud, make sure it is going to be available into multiple regions. Like let's say AWS, if your data is available in AWS, it's not just copied in one region. For a backup, it's going to be kept in 2 different regions as well. So the very best example is the Google search engine. So what happens is, even if you search for a query and if the system is down or there are some network issues, it's going to search into some other database and give some other data centers and going to give it out, because it can never go down. So in short, your system can never be down. It needs to read and write data as per the business requirement. That cannot be changed, and your system needs to be available to your business users whenever they need it. So in current cloud system, partition tolerance is default as of now. Let's say Snowflake, AWS, Databricks, and all those things. No, consistency or availability, this depends on your business requirement. Okay, so if you are doing real-time data processing like Netflix, then sometimes you might miss some of the consistency, because it's a real time. If something messed up, you cannot stop the system and look into it, right? That time consistency can be affected. Now consistency is sometimes batch processing of financial data, right? So availability can be sometimes delayed. That is, yesterday's transaction will be written today, so today's data will be available tomorrow, right? So availability can be delayed over there. So it's very rare you can have consistency, availability, and partition, but in real world, you can either have CA, AP, or CP. And most of the times it is CP or AP. I mean, if P is not there, you cannot have CA. So it's CP or AP. In CAP theorem, it's either CP or AP. So when you're designing, you need to make sure to ask the question to the interviewer. Do you need consistency or do you need availability as a priority? That is, do you need the batch processing or real-time processing in your system? Now, coming to the CAP theorem applications in data engineering. Okay. So whenever you're doing a database selection, so let's say I got a requirement, I need to design a data warehouse. So I'll give you a problem statement and a solution down as well. But yeah, so let's say if you're doing building some data warehouse, so you need to make sure that it follows the strong CP formula, that is your partition tolerance as well as consistency, because your database is not like a availability kind of thing. And anyways, if there is a feature of real time, it can do that. But for database, you need to be very sure that you have CP consistency. Okay. Now there are some relational databases which follow CP, and NoSQL or some other databases follow AP. Why? Because your relational databases like SQL Server can be on-prem. So sometimes there might not be any availability. So that's why you see relational databases can be CP and not AP. But NoSQL databases or on the cloud databases, they will have AP most of the time. Consistency can be affected based on the business requirement. Now, relational database example is like Airbnb uses a relational database like PostgreSQL. So there is a strong consistency actually for the booking information, but sometimes there can be delay when you get a response, right? And that's where your A matter comes. And that's why most of the systems who want real-time processing or real-time transaction, they move from relational database to, let's say, NoSQL or Databricks or graph databases, something like that. And that's where your EP comes in. I think, yep, Ryan, you had a question. Go ahead.
Yes, you said for availability, we might want to have data in different partitions. So if somebody wants to read them, they can do it in parallel. But doesn't that also fulfill things for partition? I kind of don't understand what would be the difference in terms of solution that would apply to each.
So partition tolerance exactly doesn't mean partitions. It means network issues. As in, let's say you have designed a system on Snowflake. Snowflake shouldn't have any network issues. If it has network issues, there should be some other nodes available where a user can access their data. That is, if your AWS is down, let's say S3 US East is down, your data will be available in US West as well, because AWS keeps the backup of the data. That's what means partition tolerance. Here, partition tolerance doesn't exactly mean database partitions.
I see. Thank you.
Okay, cool. So, yeah, CAP theorem actually applies in database selection, data pipeline designs. So, whenever you are designing your pipeline as well, like ELT, ETL, whatever you are designing, you need to be thinking about what is important, like I said, and how you're going to design the pipeline. That is how you're going to move the data from one location to another location. That time also CAP theorem is important. And in streaming architecture, again, the first main part is like partition availability is very important. And here, most of the times, it's going to be your availability. So real-time streaming or event streaming processes will have availability and partition tolerance. So this is purely theory. Understand. You can read through this document and you will understand a bit more. Coming to real world example, just let me give you. So let's say a client comes in, okay, there's a company called XYZ. They have their enterprise data warehouse in Redshift, okay, and this is their architecture. So they're getting data from SFTP, we're getting it from RDBMS as well as from REST API. They're ingesting the data through Talent, moving it to S3, and then they're moving it into Amazon Redshift using some stored procedures, which loads data into staging layers. It also creates materialized views, and then using stored procedure, it's going to create a warehouse layer. Okay. Now, when they're using Redshift, they faced an issue of excessive resource consumption, absence of data lineage, lack of change data capture, and serialization isolation issues. So these are the problems which our current client is facing. Okay. Now, based on CAP theorem, based on whatever your expertise are, as a system design interviewer, I'll ask you, you need to give me solution which will cover all these problems. Okay. Sorry. Okay. So you need to cover all these problem statements, and this is a real world interview question, I would say, for a system design. Now, what I would say is, now clients want all of his data in Amazon Redshift only, because his Tableau, his Power BI reports, downstream process, everything is in Redshift. So the question is, how would you solve this problem? Any guesses from anyone? What would you guys do if anyone wants to answer?
DBT would solve the lineage problem, but I don't know the rest.
Got it. DBT will solve lineage. Fine. What about resource consumption, change data capture? DBT will do that as well. Fine. What about serialization isolations? Because this is the biggest issue in any data warehouse. Any other guesses? Anyone?
Could you explain the issue, please?
Sure.
The biggest one. You said the one that is the
The
biggest.
issue here is in Redshift, whatever data warehouse they have, let's say they have thousands of stored procedures running in Redshift, that is leading to excessive resource consumption. Okay. There is no data lineage concept in Redshift, and they want data lineage. There is no change data capture concept as well to implement SCD2, SCD1. So they want change data capture as well. And the biggest problem is serialization isolation issues. What does this mean? If there is one stored procedure which is updating table A, and parallelly another stored procedure comes in which wants to update table A, then your stored procedure 1 is going to lock the table, and your stored procedure 2 will have to wait until your stored procedure 1 has completed its task. What will happen is, due to this, if you have thousands of stored procedures, it will take 8 to 10 hours to complete your whole job due to the table lock issues or serialization isolation issues. I hope that makes sense to everyone. Parallel processing. I think Blake says parallel processing. How will you do parallel processing in Amazon Redshift? So let's say you have two stored procedures which are running in parallel, which are writing to same table, right? And that's what causes the serialization isolation, that is table lock. Now that is the issue they want to solve. Because in parallel, there are multiple stored procedures running, and they are trying to write into same table. So that is the problem we need to solve, right? I'll tell you my solution. Okay. So I removed the stored procedure, materialized views, everything from Redshift, and brought in a new architecture of Databricks. You can bring in Snowflake as well. Yep, that is also approvable. But Snowflake and Redshift are not really, I mean, they are competitors as well. Databricks is the competitor, but it's good as a Databricks solution. Why? I'll tell you. So my solution is, your ingestion remains same. Everything comes from talent. It will go to S3. Okay. But I'm introducing Databricks on top of your AWS VPC, where we will introduce bronze, silver, and gold layer. So whatever was in stored procedures will move into Databricks notebooks, which is going to run on Apache Spark and has Delta Lake automatically installed on top of Databricks. That is going to clear my serialization isolation issues. How will it clear? If anyone knows Delta Lake, what is going to happen? Every write or every commit which comes into Delta Lake is written as a new file. So even if multiple parallel stored procedures are going to write into same table, or parallel notebooks are going to write into same table, you won't have to worry, because it's going to write into different files and there won't be any isolation issues. First issue cleared. Yep. Next issue was excessive resource consumption. Now, using Databricks notebooks, you need to design a system in such a way that is bronze, silver, and gold, that your resource consumption might be decreased. But if you ask me, it's not going to decrease the consumption. So like I explained in CAP theorem, not all of your problem statements are going to be cleared. Out of 3, 2 might be cleared, right? So my resource consumption is going to be more because I'm still keeping my Redshift and Databricks is still here. So my client has to think whether they want resource consumption to be still high and rest of the problems to be solved, or they want resource consumption to be low and they need to find another solution. So I'm thinking resource consumption high is fine. That is what I tell interview. I'm thinking or considering that extra resources, if you add extra resource, because see, if you want a solution, you need to pay for it, correct? That is why I'm considering resource consumption high is a secondary problem. Now the next problem is absence of data lineage. Databricks has Unity catalog, and you can use data lineage in Unity catalog. So that problem is also solved. Change data capture, Databricks already has it and it's inbuilt, so that is also resolved. And serialization isolation issues also resolved. So that's that's a perfect solution, right? But there can be some other solutions as well. Now, how do you give the solutions? To give these solutions, you need to know about multiple AWS technologies, multiple, let's say, Azure technologies or Databricks technologies, right? And that's when you can clear the system design interview. So the reason we give you guys multiple projects from end to end, even if you don't understand it in detail, the reason we give you those projects is you get hands-on with those technologies, right? Now, how are those technologies going to help you? Let's say real-time streaming project, S3 to GCP, DBT Dynamo project, S3 to S3 migration. If you see the number of technologies used in those projects are almost covering 80% of data engineering through AWS. Okay. So in system design, if someone asks you some questions, you might be aware that step function does XYZ concept. SNS and SQS does something, right? And the reason being adding more projects into your personalized plan is this, that you will be able to clear the system design interview. So I would suggest you guys, even if some projects are not part of your personalized plan, go ahead and explore it and implement it, because it is surely going to help you into your system design interviews. I think someone has a question. Seems like data crawl whereby multiple instances of same data are repeated across multiple platforms. Yes, you're right. So what will happen is, if I'm using Databricks, okay, whatever was happening in stored procedure, I'm storing it in Databricks. But I've distributed it into bronze, silver, gold layer. That is a medallion architecture that comes under data warehouse. So quick tip, you can watch the fundamental course, which explains about data warehousing, data modeling, data lakes, all these things. How do you design that? It's there. So I've designed a medallion architecture of a data lake where you have bronze, silver, and gold. And only the copy of gold layer, Blake, is going to be sent to your Redshift. So the only copy of gold layer is kept. Silver and bronze layer are still there. We are not storing it in Redshift. So it's not going to be exact copy in each layer. So yeah, Databricks has good data governance as well. So while designing a system, sorry, Rostan, just give me a minute to complete this and you can ask a question. So while designing a system, what I would suggest is you need to think of whatever I told, like CAP, right? That is source to target. What technology can you use first to ingest the data or extract the data? What technology can you use to load the data, that is Databricks, transform it, and maybe write it into targeted. This is one of the example of system design. So once you understand multiple technologies, it's just about shifting the technologies here and there. Yeah, Prostan, go ahead. You had any question? You had a question.
Yes, I was gonna ask a question. So a system design interview is pretty much a situation where once you get to the interview, the interviewer or the my hiring manager might pose you a problem that the current architecture is facing, and they want you to solve that problem. But
Mhm.
the question I have with your proposed solution is that you went from an existing architecture and you added something on top of the existing architecture, which are Databricks and some of the services of AWS. Wouldn't those services added onto the existing one cause a cost increase?
Correct. Exactly. Like I explained, we cannot solve all the problems in one architecture 99% of time. So I said I won't be able to solve your excessive resource consumption, because see, whatever problem you are facing in your current data warehouse, if there is no solution available in market, you will have to pay more to solve your problems. First thing. Okay. If you're not ready to pay, we cannot have a solution which is not available in market. Let's say Redshift is not write compliant. Even if
So
it is
there's a
asset
cost
compliant.
associated with Databricks?
Yes, yes, cost effective,
Okay.
the Databricks. So why is this AWS here? Because the Databricks is going to be hosted on top of AWS. In Azure, it is in-house. In AWS, it's not in-house. That's why Databricks needs to be hosted on top of AWS. We'll be soon bringing Databricks projects as well. And last line on the costing part. See, while you're designing, yeah, go ahead.
Yeah, I had a second question. So, in terms of trade-offs, for example, you went from the CAP, the CAP principle. So,
Mhm.
do we have to ask the hiring manager what a principle they want to sacrifice, or we can just advise them the principle to sacrifice straightforward?
Got it. Not exactly the principle you need to ask. So what you need to ask a hiring manager is the first question. Let's say he gave you this problem statement, okay?
Mhm.
The first question you ask is, what kind of sources do you have? He might mention REST API SQL, or he give you this architecture only, right? The questions you need to
Mhm.
ask. Are you okay to pay extra cost, or you want to sit in Redshift only and try to solve the problem? If he says no, I want to solve the problem in Redshift only, you will try to solve it in Redshift. You will try to research, okay? Now, if you're trying to do that, you need to know a bit more about Redshift. That's where those project comes into picture, where you might have implemented something, you have something on back of your mind that you faced this issue while implementing your project, that there was a serialization isolation limitation, okay? So you cannot solve this problem in your Redshift, first thing. Second thing, while you were doing projects, you did see that DBT was used for data lineage and change data capture. So you explain him, let's say there is no option available in Redshift. Are you now okay to get out of Redshift? Then he will say yes. Okay. And then you suggest something. I'm not saying you suggest same thing. You can suggest Snowflake. You can suggest Redshift Spectrum. But system design in the time of interview is not about giving you the best design. Okay. It's about suggesting a design that might be best or not even best, that might be good and that might solve the problem in the interview, not in real world. Okay. What interviewer wants to know is whether you have knowledge of multiple technologies or not. That is the main mode. See, if you tell him in Redshift, I'll install Redshift Spectrum. I'll do the parallel processing using Redshift Spectrum, and that will solve my isolation issue. Fine, that is also fine. But the more technology advancement you give in interview, it would be more better for you. So you don't need to be 100% accurate during an interview, because the interviewer is going to check if you know multiple technologies. If you are given a problem statement, can you solve it yourself? I hope that answers your question.
Got it. Thank you, man.
Yep. Any other questions here before moving ahead? Cool. Okay. So let's move ahead.
I have something to add real quick.
Yep.
Just as a point of reference or whatever, I went to a Snowflake event several weeks ago in the DC region. I live around Baltimore, and during their presentation, they indicated that one of their largest clients has one. Obviously they probably have tens of thousands, if not hundreds of thousands, of tables. But one of those tables, one single table, had over 72 trillion entries in it, in that one table. 72 trillion. So you talk about data processing and processing power. I mean, imagine running a SQL query on just that one table.
That's right. Yep.
But that's just how much data has grown. Anyway, just throw that in there for perspective.
Yep. So just FYI, I work for one of the Snowflake's biggest client called Walt Disney Company. I've designed multiple architectures for Walt Disney Company theme park and amusement parks, DPP, they call it, Disney Parks, a platform where they had almost 100 trillion records as well, because their data goes back to 1970s and 1990s. So they have data back from 1990s to 2024. So yes, you need to ask the question about how huge your data is. That is the one question I missed. Yep, you need to ask that as well, because based on that you will have to do the transformations, right? And that is where your change data capture comes into picture. Because if you have 75 trillion records, your change data capture is automatically going to capture the new records. And that is why they want change data capture. So you won't have to read all the 75 trillion records. Yep, I think that's a good thing. Good thing to be considered.
I have a quick question. So
Yes.
when you talk about new records, let's say from 1990 to 2010, so can we include them in a new backup table and create a union with the previous table so we can query accordingly? Is
Not
that a solution?
exactly you can do that, because see, let's say Shop Disney comes in with a requirement with you, okay,
Okay.
where they want to build personalized engine. That is, they want to do some personalized advertisement on their website for a particular guest. Okay. Now, in that case, you will have to build up your 365, or what they call is 365 data lake. That is, Disney has to bring the data from Disneyland Park, Hong Kong. They'll have to bring the data from their US, Tokyo, everywhere. Whatever online, offline store, everything needs to be brought into one data lake, right? In that case,
Okay.
there is no use of keeping a backup. So, yeah.
Okay.
And that's where these technologies like Snowflake and Databricks come in, where the data is stored into clustering technologies, partitioned ways, or delta lake concepts. They store data in partitions, and that's the advanced data engineering, that while you are storing the data, you need to partition them properly, all those things.
Okay. So generally, when the interviewer will understand that someone is an advanced or is trying to like is a beginner level, is when he uses this kind of terminology like technologies, right? So when where the where this like where the data
Sorry,
is
I
being
didn't get
stored.
your question.
So the interviewer, like, what does he expect? Like, let's say if he's interviewing for an advanced role, so he will understand that this candidate is suitable for an advanced role or a beginner role. So he will assess whether he's able to answer the questions based on the what technologies is being implemented in the system design, or like the just like if you don't even if you don't know the solution, even if you don't know the technologies, can you give it some solution which might be suitable? Like, will that
Got it.
will that
Got it.
suffice?
To be very honest, if you don't know multiple technologies, you cannot give the solution,
Okay.
right? Because if I give a requirement, I want to collect the logs from website, and I need to create analytics on top of it. I need to store it somewhere. So let's say you only know Redshift, okay? Just an example. But you don't know how to bring the data from your website to Redshift. Then that won't help, right? So for sure, for system design, you need to know multiple technologies. First thing, very important thing. Second, advanced can be optional. Some interviewers just see what all technologies you know, because you can jack of all trades but master of none. That can happen, right? So you need to be master of one technology. Let's say Snowflake, you're master of Snowflake. Rest of the technologies you have used, you know what does what. If you get a requirement, you can design that architecture. So second part of advancement is optional. Some interviewers might ask it because they have that specific requirement and specific role open for that. So let's say if it comes to Spark, everyone is going to dig deep into the computation, parallel processing, shuffling, broadcast joins, hash joins, and multiple things. But if you come to Snowflake and AWS, they won't go into that advancement. They're going to give you this kind of requirement, that my source is this, my target is this, design system.
Okay.
Yeah.
And we can ask how many.
Sorry,
Yeah,
go
you're
ahead.
saying so. So we can ask like how many users will use the system, what is the data
Yes.
frequency, and
Yeah. So the first thing of system design is you need to ask questions before starting designing your system.
okay.
And sorry, what was I gonna say? Okay. Moving
I have a quick
ahead.
question.
Yeah.
Do you have a list of all the different technologies that you would need to know in order to pass these interviews? You said that we cover about 80% of them. Do you have a list of all of them and a brief synopsis of what they do that we can review?
So we are collecting them together to create a document, but I have an architecture that covers 80% of it. Once we scroll down, we'll go there. I'll go there and I'll show you.
Thank you.
Okay. Yep. So these are some theoretical concepts. I'll do one thing. I'll skip because we have just 20 minutes. Okay. Because I want to explain some more real world examples. So modularity, actually it means that your data pipelines can be individually developed, tested and deployed. You don't want to club ELT, extract and load in one technology. Then your architecture is not modular. And encapsulation, as in your end user should be able to query the data properly. So let's say, like Blake said, you have 75 trillion records, and you have created a Streamlit application or Tableau report on top of that table, right? If he runs a simple report, it's taking 1 or 2 hours to load. That's not a good encapsulation. So you need to take care of that as well. And the complex data, whatever you are, doing the transformation and all those things, that should happen in one layer. That is here, all the transformation is happening in silver layer. If you consider Mendelian architecture, if you consider Kimball architecture, there is staging, data warehousing, and data mart layer, right? You have your transformation in data warehousing layer. All the complex transformation should be done in one layer. First layer should be just copy of source. Third layer should be only for business person. That's what your abstraction should take care of. So I'll move to the one real world example. Now, let's say an interviewer gives you an task to outdo one thing. I would hide that. Sorry. An interviewer gives you a task where you want to get the logs from your website, which is hosted on top of AWS, and I'll just go. Yeah, and you need to move that data in such a data warehouse that you want to create analytics on top of it. That how many users are buying my product, what is my customer acquisition cost, all those things. So you have a website, you have a requirement of analytics on top of it. You need to create reports and all. Can anyone tell me a design? Anyone? Any guesses? I'll give you like 2 minutes.
Can you tell me where the existing data is? And
it's in AWS S3. So logs are in your AWS S3. And you need to create an architecture where those logs needs to be converted into understandable data. You have all the user logs, you have who bought everything in S3. That has come through an AWS website, website hosted on AWS. Now you need to create analytics on top of that data, but that's JSON data or XML data.
Can I give some can I answer it? Some part of it. So
sure. Yep.
So basically, S3 will connect with Boto3 generally. So using Boto3, we connect to S3 object. We get the data in the form of CSV. From there, we load the data, do some manipulation for what data we need, and do some data frame operations. From data frame operations, then we again we'll have, let's say we'll have a data lake, let's say Snowflake. In Snowflake, we'll have our own schema, create a separate schema where we will load the data in periodic way. Like let's say for every half an hour or maybe every day, we load the data there. On top of that Snowflake schema, we have a Tableau dashboard. Tableau dashboard is using connector. We connect it to Snowflake. So Snowflake will using that data, we'll try to do some dashboarding from there.
Great. Okay. Great answer. Great answer. Okay. So someone said Snowpipe to load into Snowflake. Dipti said it. That's great. Rad said Snowpipe to DBT. Okay. Any other guesses? Last chance. Anyone else? Okay. Cool. So whoever answered, you directly guessed something and answered. I told you the very first thing before starting system design, you ask the questions. I told the data was in JSON, right? Let's say who I told move it from Snowflake to DBT. Okay. Let's say you are, first thing is you're getting data into one S3 bucket that is in region A. Your Snowflake is in region B. Okay. You cannot use Snowpipe in that case. You cannot move directly data into a Snowflake. So what you was answering the question using Lambda. Yes, that makes sense. It's a great approach where you take the data from S3, you move it in Snowflake. Yes, but you missed asking the first question is, can your Lambda handle that data? Lambda has a limitation of 10 GB. Okay, so let's say if you are loading it once a day and you have a data which is sitting in your logs that is more than 10 GB, the Lambda is not able to move the data from S3 to Snowflake, correct? So ask questions before going to design. Ask the questions. Let me show you basic design what I have. Okay, I don't even need Snowflake in these terms because I already have AWS. If you're going to ask me as a client to buy Snowflake account, that is going to be more costlier for me, right? I'll first see if my solution is possible in AWS. What I would do is, whenever there's a new file in my S3, I'll create an event notification using AWS Lambda. What that event notification will do, it will tell what all new files have come, and it is just going to give me event name, file name. I'm not going to process the data using Lambda. Okay, that is why Lambda is good here. Event notification will just give me what are the new files into AWS S3. I will kick AWS glue job that is going to extract the data from S3, do all the transformations and load it into Redshift. Okay, after this, I've kept an optional Lambda. If someone wants to do some extra things on top of the data, like offboard or something, someone can do it using Lambda, or I can create reports on top of this Redshift. Very simple, very crisp and clear, source to end. If there are any errors and all those, yeah, this is the basic system design what I'm telling. Okay, there is an advanced part of system design as well, where I might come in. Let's say if your Lambda fails, what is the backup process? There should be a backup process, right? When it's trying to trigger a glue job, there should be a backup process if something fails, because that log file is going to be missed. But we're not going to cover that today. We will cover it in next few sessions, those advanced sessions. That how do you handle the error pipeline? How do you handle the data quality? How do you handle the data governance and all those things? As of now, this is a simplified version which might be good in interviews. What do you guys think of this solution, or any questions into the solution?
If you actually create the Redshift spectrum, if you have a glue crawler, which is going to crawl every new either a folder based on if you're doing it, right? The data shows up in Redshift spectrum right away. You don't even have to use Lambda in the middle.
Right. What about the transformations? Because you have all the logs here.
Yeah, all the logs, and then it goes in as a spectrum table, and then you're going to do your transformations in Redshift. If it is a JSON file, you load it as a it'll actually decipher the JSON files also when you go to the spectrum, and you can do all your transformations in Redshift itself.
Got it. How are you going to schedule your Redshift stored procedures?
Okay, that Redshift has a scheduler. Either we can use that, or we have to come up with an outside scheduling thing, right? Then in that case, maybe you have to use glue or something like that. Connect the glue to the Redshift spectrum, and then run those jobs. For the transformation, if you want to schedule, or DAGs if you want to create, then you use the glue.
So at the end, you're using glue. But let me come to the first option where you gave. You can schedule it using Redshift. So Redshift is a data warehouse. Snowflake is a data warehouse. They have their cron triggers, right?
Yeah.
When you're doing a system design interview, make sure you don't suggest them use this cron trigger, because it can become messy. What happens is, if you want to create DAGs or data lineage or stored procedure lineage, that is not possible, right? You will have to get in a developer. You will have to create a table, manual tables. You will have to do everything manually. It is possible, but you have to do everything manually, right? So that's why a good system design is where you have scheduler taken care as well, where you have ELT. Your solution is absolutely right. So the only part is now you need to decide pros and cons between two different architectures. You ask yourself a question like I asked you. You move the data using Redshift spectrum. How will I do the transformation? So yeah, you answered stored procedure. That is absolutely right. Now, how do I schedule those stored procedures? Okay, I do it through cron trigger. But is it a good practice? Will a new developer, when a new developer comes in, will he able to understand that thousands of stored procedures are running? Where can he look? Where can he visibly visit that and check that? That is not possible, right?
Then that scheduler has to go into glue jobs.
Exactly. Yep. Yeah. So you need to think of these things when designing your architecture, and that's where we were thinking of using glue. And if you are using glue, there is no use of Redshift spectrum there. I can directly move the data from glue.
Yeah.
So here are the pros and cons we discussed, and the best architecture came out of it. That's how the real interview also works.
A quick question. Currently, in your architecture, where are you taking care of the transformations in Redshift, and you are triggering them by Lambda?
No, everything is taken care in glue. Glue is an ETL tool. It can extract, it can transform, and load as well. So
Okay,
glue
and
can run on top of Spark.
Lineage is also taking care of it. Taking care of.
Some part, yes, it does take care of lineage using data catalogs.
Okay, and so what would have been the problem if we used glue crawler wouldn't that be only the part where we use the glue crawler to get new data from S3 and S3 could have used
Okay, so you took the data using glue crawler from S3 to Redshift. How are you going to do the transformations?
Oh, so glue crawler cannot bring it to glue, and we do transformation there.
Oh yeah, it is possible, but why we have added is, so let's say if something fails using glue crawler, what can happen? The error files you cannot exactly identify it. So see, like I mentioned, modularity. Your modularity enables that you have independent architecture for development, testing, and deployment. And see, when you're understanding there is a new file, I'm using Lambda. So Lambda is independent of glue. Okay. If glue fails, everything fails, right? Everything is not under one system. I'm using multiple technologies enough that I can manage all those technologies. Yes, you can use glue crawler and just glue instead of Lambda. You're absolutely right. That is also good architecture. Just the thing is, you'll have to weigh the pros and cons. So I would say 50% you're right, 50% I'm right. My architecture can also go wrong, where Lambda might fail, and glue crawler can work better. In that case, it goes to the second part of the system design, that is advanced part. Partitioning, let's say error pipelines, data quality, data governance, all those things. So, but yeah, you're right. Your architecture also sounds good. Glue crawler, glue, and Redshift. That's a good option.
Thank you.
So someone asked me, what do you recommend for people who are newer to these technologies? Proceed with the study material as per the plan. Yes, so I would study as of now, proceed with the plan. Once you're done with the projects, we have a lot of projects. We are bringing at least 25 to 30 projects, which covers almost all the technologies. So based on your projects which have been assigned and based on your interest, I can assign more projects that will cover at least 80% of these technologies. I hope that answers that question. And Tanisha, yes, good question. What is the use of Lambda after Redshift? As I said, it's optional, right? So what can happen is if someone wants to do some analysis on, I agree, there is no point if Redshift is there, you want to do some analysis. So let's say if I want to offboard data from Redshift to GCP, there is a machine learning which is running on top of GCP. Let's say your website is linked with Google Analytics. So all your data are related to Google Analytics in GCP. And if you want to move the data from Redshift to GCP, this is only if your organization is huge. Then you can use Lambda, that your data comes out through Redshift and it is pushed to GCP. It's optional if you want to do some other transformation on top of Redshift.
Got it. Thank you.
Yep. Any other questions? We have just 5 minutes. I know I was going to tell you guys 80% of architecture, which covers everything. This was that, but I think we'll do that in next call. I have architecture that will cover almost 80% of requirement. Like you give any requirement, that will be covered here. So I wanted to have that chat with everyone. Like you guys give me a requirement, I will show that most of them are covered here. And this is what we have assigned you in projects as well. So 75 to 80% requirements in system design will be cleared by you guys. But I think we'll have that in next call. I'll share this document. And yep, I think this is.
How do we get access to this document? Go to the school and then download it?
Yes, go to the school and download it. I'll be uploading it there.
Okay. All right.
Yep. I'm open to the questions. Last 4 minutes. If any other questions, anything else.
I think it was Jay who asked a question about, is there a list of all of these technologies? And you said you're working on it and putting together this. I think that list that you're putting together is going to have the name of the technology and pros and cons and all of that. But I think even just the names is going to be a very big step forward, because it's going to allow us.
Yeah, it's gonna help a lot.
Yeah, it's going to help a lot.
So what our plan is, how we do is, we are going to assign you more projects. Whatever document I'm going to do, almost all those technologies are going to be covered into your project. Whatever project you're going to do through DA Academy, okay? Now, if you have any other questions, we will have one-on-ones and all those things, right? That time, we will cover those technologies specifically if someone has doubt of one technology, or else we'll have it in group call as well. So this architecture, you see I'm using AWS DMS, Kinesis, Kairos, S3, API Gateway. This covers everything that is coming from RDBMS and some APIs hit as well. And ELTs covered everything over here. So whatever document I'll be giving you, that won't just include technology names, that will include project associated with the document, and we will add more links. Yep.
Perfect. Thank you very much.
Yeah, awesome.
Go ahead, Blake. G maybe. Yeah. Who wanted to say first? Yeah. Go ahead. Was it Blake or G?
No, I just said awesome. I'm waiting for that document.
Yep. Okay, I think Blake doesn't have any question, and someone else was talking, right?
Yeah, Nina, can you show the diagram again once again? The overall architecture that you said.
Sure.
So this is where, like, so everything happens. You said most of the technologies and the flow, like most of the questions will drill down to some part of this diagram, you said, right? So so here the data ingestion happens, and then the transformations happen here, right? Okay. Yeah. Just want.
So let's say if you're DMS, you have RDBMS source, Oracle, Postgres, anywhere you're getting data, it comes through DMS, goes to Kinesis, Kairos, S3. If someone else wants it in downstream, let's say Grafana and all, they can directly take it from Firehose. They won't have to go back to source. That is why we have Kinesis and Firehose. S3, you have two options, where it is real time or batch. If you're real time, you can use Snowpipe, you can load it to Snowflake, and then use task and streams and do all the transformations. If your requirement is batch processing, you use dbt, do the dbt cloud scheduler, load it into your Snowflake database. For data quality, we have our inbuilt tools which we have built. You can suggest that, or now data quality and all is already available in dbt. So that can be taken care by dbt. You can build your own monitoring system on top of Snowflake, where you analyze all those tasks and streams. I think, yeah, that I'll cover in next call, how all those
Understood.
things will happen.
Thank you. This is helpful. So generally, if you have source as SAP, also it will work, right? Yes.
So
Okay,
SAP, let's say, if they are ready to hit my API and send me the data through API,
okay,
they can send to my API gateway.
okay,
My API gateway is going to be available for them. So I can do
understood.
post in my API gateway. So they can
So
post it
that
on their.
you're actually expecting them to write a call to
Correct.
post it to our API, right?
Yes, yes. If we want to pull, we need either a glue job here, or else they will have
And
to
then
expose their
we need to
API.
get the access to their SAP systems also. They have to provide an API or something like that. We can pull it, right? From their API.
Yes, if they do that,
That is
we
also,
can do it through API gateway.
yeah. Okay.
Another option. If they open their system for us, open their API, API gateway can do the get command and it can write the data.
Should it be the same for Oracle Financials or any other ERP systems, right? It should be the same.
If API is available, yes, get API gateway is a solution. If there is a Kafka and all those things, MSK and all those things are available. But yeah, we'll have detailed discussion in next call. Don't worry. So I'll keep doing one thing. I'll give 1 hour just for this architecture and the architecture in Azure as well. So whatever problem statements you guys think can come off, we'll discuss all those things there.
All right. Perfect.
Yep. I hope this was helpful. I'll be sharing the link in classroom in the school. Let me know if any other questions, guys. Thank you. Good day.
Very helpful. Thank you very much.
Thank you so much.